Hi guys, today we're going to look at exact values of trig. Now, you can use a calculator to do this, but the purpose of this video is to show you how to do it without a calculator. The reason being is because this is likely to be tested on the non-calculator paper at GCSE, and generally the question will be something along the lines of what is the value of sine 30, and therefore you'll be expected to just recall the value of what sine 30 is. I do suggest that once you have watched this video through, that you copy this table into your notes and you fill it in with the exact values that we work through as we go forward. So, to show you how to do this, I'm going to start with a triangle. Obviously, basic trigonometry SOHCAHTOA type triangle. Here you can see I have an isosceles triangle. Both lengths here are one unit. What I need to do is I need to work out what the length of this is, and what I'm going to do is just use basic Pythagoras to do this. So 1 squared plus 1 squared is equal to c squared. So 1 plus 1 is equal to c squared. 2 is equal to c squared, and therefore the square root of 2 is the value of c. So this value here is root 2. Because it's isosceles, we know that these two angles must be equal. We know it's a right angled triangle, and therefore both of these angles must be 45 degrees each. So looking back at the table, from this triangle that I've got, I'm going to be able to work out what sine of 45, cos of 45 and tan of 45 is. So if I look and I use this 45 degrees, this is my opposite, this is my adjacent, and this is my hypotenuse. I know from basic trigonometry that sine theta is opposite over hypotenuse. So if I say sine of 45, sine of 45 is my opposite, which is 1, over my hypotenuse, which is root 2. So the exact value of sine 45 is 1 over root 2. So I can fill that in here, 1 over root 2. Now to do the same here, but for cos theta, I know cos theta is my adjacent over my hypotenuse. So cos of 45 is my adjacent over hypotenuse, which is also 1 over root 2. So I'm just going to fill that in my table here. And finally, tan theta is opposite over adjacent. So tan 45 is my opposite, which is 1, over my adjacent, which is also 1 over 1, which is just 1. So again, I can fill in that value there. So that's how I work out the values for the functions of 45 degrees. Now to show you how to work out the functions for 30 degrees and 60 degrees. So here is a triangle. This time I've got an equilateral triangle. Now I don't have a right angle in it, so what I'm going to do is I'm just going to split that triangle straight down the middle, which will make that a right angled triangle, which I've drawn just to the right hand side here to show you. I've split this angle in half, therefore this angle here, which is this angle here, must be 30 degrees. This length here has also been split into 2 in half, therefore that length there is 1. We know that length is 2 because it's given there, and to work out the length of this side, I again just need to use Pythagoras. So I know that a squared plus b squared is equal to c squared, using that as my a, that is my b, and that is my c. So a squared is 2 squared, which is 4. Subtract the 1 squared from both sides, which is 1. So a squared is equal to 3, therefore that length is root 3. So just to fill that on here, that length there is root 3. Okay, so using this triangle now, I've got 30 degrees here. Angles in a triangle add up to 180 degrees, therefore this angle must be 60 degrees. This is what's going to enable me to work out the values for 60 degrees and for 30 degrees. So, looking for 30 degrees, this is my adjacent to the 30 degrees, and this is my opposite to my 30 degrees, and this is my hypotenuse. So, sine theta is equal to my opposite over my adjacent. Remember, we're working for sine 30 at the moment, so sine of 30 is my opposite, which is 1, over my hypotenuse, which is 2. So sine of 30 is a half. Cos theta is my adjacent over hypotenuse, so cos 30 is the adjacent, which is root 3, over the hypotenuse, which is 2. So cos 30 is root 3 over 2. And finally for tan theta is my opposite over my adjacent. So tan 30 equals 1 over root 3. Tan of 30, 1 over root 3. Okay, so now I am working with 60 degrees, and therefore this time the 1 is the adjacent to the 60 and the root 3 is the opposite. So for sine 60, I'm going to have my opposite, which is root 3, over my hypotenuse, which is 2. So sine of 60 is root 3 over 2. Cos of 60 is my adjacent, which is 1, over my hypotenuse of 2. So cos 60 is a half, and tan of 60 is my opposite, which is root 3, over my adjacent, which is 1. So tan 60 is root 3. Okay, so we've got all the values in there for 30 degrees, 45 degrees and 60 degrees. Now to show you how to find the values for 0 and 90. So this comes from the graphs of the trig functions. So sine theta, the general graph for y equals sine theta looks like this, where this pattern repeats every 360 degrees. I have got this value here, which is at 0, therefore sine of 0 is at 0. Now this point here is where 90 is, and your maximum is at 1, so sine of 90 is 1. The graph of cos theta looks like this, with this pattern repeating every 360 degrees. This value here is 1, therefore cos of 0 gets me a value of 1. This value here is 90, and therefore cos of 90 gets me 0. Finally, the graph of tan theta, y equals tan theta, looks a little like this, where this pattern, this shape here, repeats every 180 degrees. And therefore, tan of 0 here is 0. And at this point here, there is an asymptote. And an asymptote is where the graph, this will continue to rise up and up and up, but it will never actually reach the value of this asymptote here. Same with this will go down and down and down. It will still get very, very close to the asymptote, but it will never touch it. And the value of that part there where the asymptote is at 90, and therefore there is no value for tan theta at 90.